angular momentum and moment of inertia. The first relation is relation between angular momentum and moment of inertia. We will write down this angular momentum in terms of moment of inertia. See how we will discuss this. Suppose we have a particle, say a particle of mass m, which is located at point P at a distance r from this vertical axis AB. P is a point which is at a perpendicular distance r from a vertical axis AB. Suppose this particle rotates about this vertical axis AB with an angular velocity omega. Since angular velocity is the axial vector, therefore this will be along the axis of rotation. The particle which is at point P, this particle rotates about the vertical axis AB with an angular velocity omega. Suppose V is the linear velocity of a particle. This is always tangent to its circular path. Now, the angular momentum of this particle about this axis of rotation, this is given by R is equal to, L is equal to R into P. That is linear momentum, product of linear momentum and perpendicular distance of the particle, or we can say perpendicular distance of the line of action of linear momentum from the axis of rotation. This linear momentum, as you know, this is equal to product of mass and velocity. Let us put the value of P in this equation. We get L is equal to R M, okay, R M V. Let me call this equation number first. What is this? Perpendicular distance of the line of action of linear momentum from the axis of rotation. What is M? It is the mass of the particle. What is V? The velocity of the particle. We know that this linear velocity is related to the angular velocity by an expression V is equal to R omega. Let us put the value of V in this equation. We get L is equal to R M into R omega. We can write down just like this. This is M R square omega. Now, this mr square, this is the moment of inertia of this particle about the axis AB. But omega. But mr square is equal to I. What is I? I is the moment of inertia of particle about the axis of rotation. About the axis of rotation. We will put the value of mr square in this equation. We get L is equal to I omega. L is equal to I. हम लोगों को निकला L is equal to I omega. This is the required expression. Here, or this is the required relation between angular momentum and moment of inertia. From this equation, we can also define the moment of inertia again. If omega is equal to 1, that means if the particle is rotating about the axis AB with unit angular velocity, then equation second becomes L is equal to I into 1, or we can write I is equal to 1. I is equal to L. So, from this equation, we can define moment of inertia. Hence, moment of inertia of a particle about a given axis, which is AB here, about a given axis, is equal to the angular momentum of a particle rotating with unit angular velocity about that axis. जो moment of inertia है, ये किसके बराबर है? Angular momentum of a particle about a given axis rotating with unit angular velocity about that axis. तो हम ऐसे लिखेंगे moment of inertia of a particle about a given axis is equal to angular momentum of a particle rotating with shabash, rotating with what angular velocity? Unit angular velocity. Rotating with unit angular velocity about that axis. Rotating with unit angular velocity about that axis. So we find an important relation between angular momentum and moment of inertia. L is equal to I omega. ठीक है ना? L is equal to I omega. Very nice. Go